Many people include nuclear power within the sort of renewable energy family. Now we have to actually look at this in quite a serious way because different countries have decided to go down that route. So for example, about 80 to 90% of all the electricity generated in France is from nuclear power stations. And many other countries are thinking about renewing their power stations and actually generating clean electricity from nuclear. Now, the interesting thing for me, personally, is I think this is a democratic decision, that countries have to decide for themselves whether they wish to actually go down that route. So, for example, Germany has always voted with their feet and have said no nuclear. Japan has gone for nuclear, and so has France. But let me actually extract some of the facts about nuclear. So the big problem with nuclear is that everybody assumes that it's carbon neutral. But the first thing is you have is that a nuclear power station is really just a huge, massive ball of concrete, which is a huge carbon footprint in its own right. The actual fuel stuff has to actually then be mined, the uranium has to be brought, so that has a part of a carbon footprint, and then, this is the problem facing France, you then have to decommission those nuclear power stations something like 40 years after they have been built. Now the problem there is, what do you do with decommissioning all of that concrete and all of that material which is radioactive and has to be stored for 10,000 years before it's safe? And no one's actually really worked out how much work you have to do to actually protect that. There's also another problem. Japan has a wonderful system to protect themselves against earthquakes and tsunamis, but even their incredibly advanced system, when they were hit by the tsunami, their nuclear power station, Fukushima, was actually damaged. And again, the local area had to be evacuated. So again, the problem is that societies have to decide whether nuclear power is worth the risk or whether actually, if you go down the solar, the tidal, and actually perhaps the wind route, you might have a much cheaper option in the long term and actually a safer option. One of the key things is that we now know that many countries are locked into a fossil fuel economy. Again, fossil fuels are very cheap because of the subsidies. Many countries have reserves, so they can actually use that. And again, if you think about it, people need energy for their livelihoods, for clean water, and for industry. So again, you have to balance the need of the energy versus the actual availability of the fuel. Now, one of these solutions could be that in the short term, we could have carbon capture and storage. What that means is, okay, you can have a power station, perhaps using natural gas or methane from fracking, but you capture the CO2 after you've burnt the gas, you then capture the CO2 in the fumes, and then what you do then is you then pump that and store it. Now, the interesting thing is the oil industry has been using carbon dioxide for tens of years, because what they do is when you get to the end of a reserve underwater or in the ground, what you do is you start to pump carbon dioxide into the reservoir to get the last gas and the last oil out of the reserve. You then fill up the reserve with CO2 and then you cap it off. So there are places, deep places in oil wells, in saline aquifers, that we could store quite a lot of CO2. Now the interesting thing is this is great, but at the moment we don't have a proper industrial scale example to show A, whether it works, B, how much it will cost. And therefore what we need to do is have these examples around the world to show whether carbon capture and storage would work, and also then make sure it's safe. Because one thing you must remember, carbon dioxide is an incredibly dangerous gas. The problem is it's heavier than air, so if you release a very large amount of it, it sits near the ground. And of course, it's because it's dense and therefore excludes the other gases, can be very, very dangerous for human and animal health, because then it prevents people actually breathing. There's an example in sort of Cameroon, a volcano basically was slowly bubbling into the lake, carbon dioxide, and the water was becoming super saturated in carbon dioxide. Nobody knew this. And then one day what happened in 1988 was there was a landslide which mixed up all the water, and all the gas then came out, came down the hill, floated over the villages, and 2,000 people suffocated, and so did all their livestock. So we know that concentrated carbon dioxide is a danger, so we need to make sure that not only do we capture it, we transport it safely, and we make sure we definitely store it safely, that it can't come back out. Many people, particularly scientists and politicians, are concerned that even though we have now pledged to start reducing carbon emissions, we may not be doing it quick enough. And so they're looking at alternative, the plan B. And what you find is people always talk about geoengineering. Now, geoengineering is a term which covers a multitude of sins. And again, I'm going to try and take those apart for you so you can see the good, the bad, and the absolutely insane. Okay? So geoengineering starts off with, well, how do we actually capture carbon, take it out of the atmosphere? So the first thing is that many people see that reforestation, replanting, rewilding of our planet would be incredibly good. I do a lot of work in East Africa, and when I fly up the Rift Valley, I look out and my students look at the landscape and they go, oh wow, this is the savannah. And I go, no, we're 1,000 meters above sea level, it should be forest. And what you find is that you see clouds of dark figures on the landscape. Those are goats and cattle. And what you find is that they basically have deforested the whole area, and you find that you have very low grass and a few very large trees. And so we have vast areas of Africa, Europe, North America, and of course China that we could reforest. And actually planting trees is a fantastic way of actually taking CO2 out of the atmosphere and converting it into basically plants. It also has another advantage. China had a huge problem in the 1990s, which was the lowest plateau had turned into a dust bowl. They'd overworked it, very much like the 1920s in the USA, and therefore the farmers weren't being able to produce food. This had been the breadbasket of China for the last 3,000 years. They asked the scientists, and the scientists said, well, look, all the trees have been cut down. This has actually caused huge problems. So they mandated that each person with their farm had to replant and start planting trees. Within a decade, firstly, the soils were stabilized because you had the trees holding in the soils, so therefore the agriculture could actually start up again. And what also was amazing is because trees transpire, they put moisture back into the atmosphere, you start to moisten the atmosphere, and actually you make rainfall locally more regular and actually more controllable. And so it's interesting that reforestation has positive effects not just on climate change, not just on local climate, but also the water cycle as well. But those are some of the positive ones for geoengineering. The other ones are things like carbon capture and storage, where take CO2 out of the industrial process as it's being produced and then storing it. And then there's the more far-fetched ones. So, for example, there are some scientists that are suggesting we should have plastic trees. These trees have a special secret coating, which between you and I is caustic soda. And of course, when air blows over it, CO2 is absorbed by the caustic soda. You can then take those down, and then you can wash it, and the CO2 goes into the water. Now, of course, I asked the question, what happens if it rains? Because then you lose all of that. So they then told me they'd need umbrellas over the plastic trees to stop the rain. So as you can see, some of these ideas aren't quite as well thought through as you would hope. The other ones, and these are the ones that we definitely need to avoid, these are the ones that say, hey, look, the planet's going to warm up. How do we cool the planet down? So one of them is, well, why don't we shoot lots and lots of small mirrors into space, okay? We'll throw them up there, and these little mirrors will start to reflect sunlight away from the planet, therefore we get less sunlight so the planet cools. That's great. So what you're doing is you're changing the reflectivity of the Earth and cooling it down. But what these people don't understand is you may get the average temperature down, but it's not the same planet. So when we've done models of this, what happens is, of course, the poles still warm up and the tropics cool down, So you have a completely different world. You don't have the same world, and therefore you're changing climate just as much as if you hadn't actually put them up there.